The Steducentre Grade 9 A&A Exam Review Maths Part 3. Question 4. Factorize fully. 4.1. X squared minus x times y. 4.2. 2 times, in brackets, x plus y, close brackets, minus t, open brackets, x plus y, close brackets. 4.3. X squared minus 81. 4.4. X squared plus 7x plus 6. When we are factorizing expressions, we need to remember that factorizing an expression is the opposite of expanding it. For example, if we had a plus 1 in brackets times a plus 2 in brackets, if you wanted to expand or multiply it out, you would end up with a squared plus 3a plus 2. And if you wanted to factorize a squared plus 3a plus 2, you would have ended up with a plus 1 in brackets times a plus 2 in brackets. Often we expand an expression when we remove the brackets, and we factorize an expression when we write it with the brackets. If you have an expression in the form of a difference of two squares, for example, identify x squared minus y squared, which will equal to x plus y brackets, x minus y brackets. You need to take out the common term, if any, and then use the identity. For example, 108x cubed minus 3x is equal to 3x. In brackets, we have 36x squared minus 1. This can be broken down further with 36x squared equaling to 6x squared and minus 1 equaling to minus 1 squared. The final answer will be 3x in brackets 6x plus 1 close brackets 6x minus 1 close brackets. If you're looking at an expression in the form of a perfect square, then x squared plus minus 2xy plus y squared is equal to x plus minus y squared, which is equal to x plus minus y brackets x plus y brackets. If you're using the identity x squared minus 10x plus 25, it will equal to x squared minus 2 times 5 times x plus 5 squared, which is equal to x minus 5 squared, which is equal to x minus 5, x minus 5. For question 4.1, x squared minus xy, you take out the common item, which is x, and you're left with x brackets x minus y close brackets. In 4.2, you've got 2 times x plus y close brackets minus t x plus y. You take out the common items, which is x plus y, in brackets, and you are left with 2 minus t. 4.3, you have x squared minus 81. It will give you x plus 9, brackets x minus 9. In 4.4, you have x squared plus 7x plus 6, which will give you x plus 6, x plus 1. Remember, the 6 plus 1 gives you the 7, and the 6 times 1 gives you the 6. Question 5. Solve for x. 2x plus 6 is equal to 0. 5.2. 2x minus 1 over 3 plus x plus 2 is equal to 0. 5.3. X plus 4 brackets x minus 4 brackets is equal to 0. If we had to look at an example, 2x minus 4 is equal to 10, you will add 4 to both sides of the equation, which will give you 2x is equal to 14. You'll then divide both sides by 2, and your answer for x will equal to 7. An additional example, x squared minus x minus 6 is equal to 0. You first identify the factors, so x minus 3 in brackets times x plus 2, which is equal to 0. Then you will look at the one, x minus 3 is equal to 0, or x plus 2 is equal to 0. Then when you solve for x, you will realize that x is equal to 3, or x is equal to minus 2. For question 5.1, 2x plus 6 is equal to 0. You take the 6 across, so 2x is equal to minus 6. You then divide by 2, x is equal to minus 3. For 5.2, 2x minus 1 over 3 plus x plus 2 is equal to 0. You will multiply by 3 to get rid of the denominator, in the fraction. So 2x minus 1 plus 3 times x plus 2 times 3, which is equal to 0. 2x minus 1 plus 3x plus 6 is equal to 0. 5x plus 5 is equal to 0. 5x is equal to minus 5, and x is equal to minus 1. In question 5.3, x plus 4 in brackets times x minus 4 in brackets is equal to 0. X is equal to negative 4, or x is equal to 4. Question 5.4, x squared plus x minus 6 is equal to 0. In question 5.4, x squared plus x minus 6 is equal to 0. You first find the factors. This would be x plus 3 in brackets and x minus 2 in brackets, which is equal to 0. So x plus 3 is equal to 0, or x minus 2 is equal to 0. So x is equal to minus 3, or x is equal to 2. For question 6.1, complete the following table. We have x, which is 1, 2, 3, 4, and 6, and y, which is minus 3, minus 5, minus 7, minus 9. Question 6.2, write down the value of y in terms of x to describe the relationship between x and y in the above table. So y is equal to what? And 6.3, determine the value of x if y is equal to negative 51 in the above table. Number patterns have a relationship with each other, something in common that works for a whole pattern. In this case, the pattern is decreasing by 2 with each term. If you look at 6.1, when the value of x increases by 1, the value of y decreases by 2. If you were to complete the following table, for 6.1, x is equal to 6, y will equal to negative 13. For 6.2, if you write down the value of y in terms of x to describe the relationship between x and y in the above table, y is equal to negative 2x minus 1. In 6.3, if you have to determine the value of x if y is equal to negative 51, you will substitute negative 51 for y. So negative 51 is equal to minus 2x minus 1. 0 is equal to minus 2x plus 50, and x will equal to 25. In question 6.2, we multiply n by negative 2 and then subtract 1 to get to the next term in each case. This is expressed in the form of x and y and is shown below. Y is equal to negative 2x, negative 1. Question 7.1. Use the equation y is equal to 2x minus 1 to calculate the values of y in the table below. So x is minus 1, 0, or 3. You will then substitute the values of x in order to determine the values of y. If you substitute minus 1 into the equation, y is equal to 2x minus 1, y is equal to 2 times minus 1, which will equal to minus 2 minus 1, so x will equal to negative 3. Y is equal to 2x minus 1, where x is 0, y is equal to 2 times 0 minus 1, y is equal to 0 minus 1, y is equal to minus 1. Y is equal to 2x minus 1, where you substitute 3, y is equal to 2 times 3 minus 1, y is equal to 6, minus 1, y is equal to 5. In question 7.1, using the given equation, in each case we substitute the x in the equation with the value of x given in the box to find the value of y. Y is equal to 2x minus 1, substitute the x with minus 1. Y is equal to 2 minus 1, minus 1. Y is equal to minus 2 minus 1, which is equal to minus 3. And this is the same method you use to calculate the rest of the items. Question 7.2. The points A, minus 1, minus 2, B, 0, and 1, and C, 1 and 4 are given. 7.2.1. Plot the points A, B, and C on the grid below. 7.2.2. Draw a straight line through the points A, B, and C. To plot the items, we will go to minus 1 on the x-axis and minus 2 on the y-axis. For B, we will start off at 0 on the x-axis and go to 1 on the y-axis. And for C, we will start at 1 on the x-axis and 4 on the y-axis. It is important when you plot that you include the coordinates for the x and the y next to the relevant letter. Question 7.2.3. Calculate the gradient of the straight line through points A, B, and C. And 7.2.4. Determine the equation of the straight line that is parallel to the straight line through points A, B, and C if it passes through the point 0 and 4. If we need to find the gradient, we need to use the formula m is equal to y2 minus y1 and x2 minus x1. In the example we have used here, it will be m is equal to 4 minus 2 minus 3 minus 3. M is equal to 6 divided by minus 6, which is equal to negative 1. So the gradient through points A, B, and C is 4 minus 1 divided by 1 minus 0. So my gradient is 3. If you want to work out the equation of a straight line that is parallel to the straight line, the line graph translates 4 units above the original line graph. Hence, we have plus 4 in the equation. Y is equal to m, which is the gradient, x plus c, the y-intercept. So your answer will be y is equal to m, which is 3x, plus 4, which is the y-intercept.
Thank you for watching the Steducentre, turning ordinary learners into extraordinary leaders.